We are continuing part 2 of the recording on slide 6. And remember, we ended off by stating that we are going to go through the rules for indefinite integrals. Now, the first rule, and probably the most important rule, is the integral of a power function. And this is this rule over here. So if you have the integral of a power function, x to the power of n, then the indefinite integral of that power function with respect to x is going to be given as such. Now, how would you go about using this rule? So you can see that x is raised to the power of n. So you would need to add 1 to the power of n, then divide by the number that you get. So then it would be 1 divided by n plus 1. So if n was 2, as it was in our very earlier, much easier example, it became 2 plus 1, which gave us 3. And remember, the coefficient that was in front of the x was 3. So then if you divide that by 1 over n plus 1, which was 2 plus 1, 1 over 3, you ended up getting 3 over 3, which just gave you 1. So in that example, the answer was just x cubed. And then, of course, we have to add the plus c, which is our constant of integration. The next rule that you need to apply is the integral of the sum or difference of two functions, and that is obtained by integrating the functions separately, as you can see here, and then adding or subtracting. So this rule here essentially incorporates three rules into a single rule. This plus sign could also be a minus sign. Hence, I said it's the indefinite integral of the sum or difference of two functions. So this could be a negative, and then it would be the difference of two functions. Notice that we have two functions here. We have f of x and we have g of x. So therefore, I've stated it would be obtained by integrating the functions separately, as we have here. That is integrated separately. And then you would add, or if this was a negative, you would then subtract. Now, also notice that in front of this function f of x, we have a constant a, we have a constant multiple a, and then we also have b in front of this function g of x. So we are combining rules in this particular rule. So let's start with dealing with the constant multiple of a function. So if you have the integral of a constant multiple of a function, then in order to obtain that integral, you would need to integrate the function and then multiply by the constant. Now let's look at this part. So again, if we want to get the integral of a constant b times a function g of x, it is obtained by integrating the function g of x and then multiplying by the constant b. So notice in between the integral sign and dx, we have the function g of x. So we integrate that and then multiply it by this constant b, as it was done here for the function f of x. Integrate that, then you multiply it by the constant a. And then, of course, to get the integral of the sum or difference, we would integrate this separately, the two functions f of x and g of x separately, and then add or subtract depending on what the operation is. So it seems complicated, but if you look at the upcoming examples, you will see it is fairly straightforward. Right, so here we have the integral of a constant k, so k being 9, of course k can be anything. So we have the integral of a constant, and it is simply going to be that constant times x plus your constant of integration. So always remember, if you have your integral, your indefinite integral of a constant, notice there's no x here. So your integral of a constant k, for more general terms, with respect to x, then what you get is the constant k times x plus your constant of integration. So if we have a look at this example, remember this is your integrand. So we need to figure out what was the function that when you got the derivative, it gave you a value of 9, right? So that would imply that x over here is raised to the power of 0 because x raised to the power of 0 is just 1. So you would not then write the 9 times 1 there. It would just be 9. So therefore, as x is raised to the power of 0, then we say n plus 1, so 0 plus 1. That just gives you x to the power of 1. Then with our coefficient 9, remember we have to say 1 over n plus 1. And n was 0. So therefore it becomes 1 over 1, which is just 1 times 9. So we just have 9x plus c. So as that rule states, when you do your operations, your calculations, you do not even have to give this step because the integral of a constant k is always just going to be the constant times x plus c. Of course, if we want to get the derivative of this now, the derivative of 9x plus c is simply going to be 9. Now, let's have a look at this example over here. F of x. So remember, this represents your antiderivative. This is what we want to find. It is equal to the indefinite integral of x with respect to x. X is raised to the power of 1. So n is 1. So therefore, it is x to the power of 1 plus 1. And then in front of that, we have 1 over n plus 1, and n was 1. So it's 1 over 2. So that is a half x. If we add those two, we get 2. So a half x squared. And don't forget your constant of integration. So if we were to differentiate this now, remember this is your antiderivative or your integral. If we differentiate that, are we going to get what is in between the integral sign and dx? Let's see. 2 times 1 over 2. It's 2 over 2, which is 1x. And there we go. Let's look at another example. Here we've got f of x is equal to the indefinite integral of x to the power of 4. So this is our integrand with respect to x, or dx. So therefore n is 1. So therefore I'm going to say x to the power of n plus 1, 4 plus 1. It's going to give me x to the power of 5. And then I say that is multiplied by 1 over n plus 1. N was 4, 1 over 5. So I have 1 over 5 x to the power of 5 plus c. Don't forget that. Do not omit that. And again, if you were to check this, 5 times a fifth is 1. X raised to the power of 5 minus 1 is going to give me 4. So I just have x to the power of 4. If I differentiate that, I get what is over there. So you can always check your work with indefinite integrals. One more. Here we've got f of x is equal to the indefinite integral of 10x to the power of 4 dx. Here we've got a constant. So we take the constant in front of the integral sign. So first deal with the function, then multiply it by the constant. So notice I've got my constant there, but I'm going to multiply that once I've dealt with the function. So x is raised to the power of 4. So n is 4. So therefore it is x to the power of n plus 1, which will give me 5. And then I've got 1 over n plus 1. So 1 over 4 plus 1 is 1 over 5 x to the power of 5. Now I can multiply this by the constant k. So therefore, I'm going to have 10 times 1 over 5, which is going to give me 10 over 5 x to the power of 5 plus my constant of integration. That simply gives me 10 over 5 is 2x to the power of 5 plus c. And let's just check. If we differentiate that, will I get this? So 5 times 2 will give me 10 times x raised to the power of 5 minus 1 is 4, and that gives me 10x to the power of 4. And your constant of integration will differentiate to 0. Let's look at the final two examples. Here, f of x is equal to the indefinite integral of 2x squared minus 4x to the power of 6 dx. Notice that here we've got two functions and they have constants. So therefore you're going to deal with this and this separately. This is, for example, your f of x, and that is your g of x. And we're getting the difference between the two. So integrate them separately. So therefore, while dealing with the first function, we're going to take the 2 in front of the integral sign, and then we're left with x squared between the integral sign and dx. Then we have minus 4 because we're going to take the constant in front of the integral sign there. And between the integral sign and dx, I just have x to the power of 6. So let's integrate these separately first and then subtract. So therefore, I've got x squared, n is 1. So therefore, it's going to be x to the power of n plus 1, 2 plus 1, which is going to give me 3. So therefore, I know in front of x, it is 1 over 3. It is always 1 over n plus 1. And if n is 2, it's going to be 1 over 3 times that constant. So therefore, it will be 1 over 3 times 2 will give you 2 over 3 x cubed. Now we'll deal with this function. X was raised to the power of 6, so n is 6. So therefore, it is n plus 1, 6 plus 1 is 7. So therefore, it is 1 over 7, x to the power of 7. So now we need to multiply that by that constant, which was minus 4. So it becomes minus 4 over 7, x to the power of 7, plus your constant of integration. Final example, f of x is equal to your indefinite integral, and now we've got 3. We've got 2x squared minus x plus 1 with respect to x. So deal with each function separately. Yeah, I'm going to take this constant in front of the integral sign, and then what I'm left with between the integral sign and dx is x squared. Yeah, I'm going to take the minus 1 because that coefficient is 1 in front of the integral sign, and then I've got x between my integral sign and dx, and then I've got the integral of a constant. So now let's solve. So n here is 2. So therefore, x is raised to the power of n plus 1. 2 plus 1 is 3. So therefore, this will be 1 over 2 plus 1. Also 1 over 3 times 2. So 2 times a third is 2/3 x cubed. Then I've got x raised to the power of 1. So therefore, it is 1 plus 1, x squared. So therefore, it is 1 over 2 times minus 1. It's just minus a half x squared. And then this was just your constant k. And in this case, the constant is 1. So remember that is simply going to be 1x. And then lastly, you add your constant of integration. So here are 3 homework exercises taken from the textbook, as well as the solutions in the next slide. First attempt them, then check your answer in the next slide. And then we're going to continue with applications in the final audio.